Thank you for being here. I'm super excited to talk to you about building Angular applications at scale. This is what I've been working on for the last couple of years, and it is almost ready for you guys to try under the Angular Labs logo that you see here that Brad announced this morning at the keynote. I'm Alex Eagle. I work on the Angular team at Google. Let's jump in. So I want to set this up by talking about two different groups of users. The first group is your users, people who use the web. And what do they want? So one way you can divide this, do they want the power of a downloaded desktop application that can do lots of stuff, but they have to download it? Or do they want to just be able to click a link and go straight to your content? And the answer is, they want both. This is not a real survey. So this is, we kind of know this. This is why we're all trying to learn about server-side rendering and progressive web apps, because this is legitimately challenging to do. Very similar question, what do you want as web developers? And since I work on build tooling, you're really my users. Do you want safety, higher-level concepts like languages that compile down to JavaScript in build tools, or do you want to have your development cycle be really fast all the time? And of course, you want both. Also, similarly, not a real survey. So how are we doing right now? I think my guess is that this is not working that well when you get to larger scale. So when you have a lot of source lines of code, I think your application, your development kind of starts to suck. I know about this because we have a lot of code too. So I work on the Angular toolchain at Google, and we've had to solve the same problem because we have the scale. So one example app, we have the Google Cloud Console that Brad showed this morning. They have 6,500 TypeScript sources, and 1,500 of those are Angular sources. So if you worked on that project and you make a little change, and you want to see it show up, that's a lot of code to rebuild, right? And if you look across all of Google, we have 35,000 files in TypeScript, and 16,000 of those are Angular sources. When our team makes a change to the TypeScript compiler configuration, or we roll out a new version of Angular, which we do several times a day, we have to retest all this stuff again. So how do we do this without it sucking? And just to be clear, when I say suck, that's nominative, I think, and it should be normative. I'm not sure if those are the right words. What I mean is, like, how much slow is too slow? So I'm going to put a line in the sand. I'm going to say 2 seconds is how long you should expect to wait. 2 seconds between editing a file and seeing it show up in the browser. And I'm saying that this is a service-level objective, which is really a term we use when you run a back-end service that needs to return data. But I want to think about it in the same way, because we want to set expectations between people who work on build tools and people who use them about, at what point should you complain? So I've talked about this before. That's me talking about this Bazel tool, and it wasn't ready yet. And I said, sorry, you can't do this. And then Brad went to ngconf, and during the keynote, he said, we are working on this. And so today, I'm happy to say it's soon. You can do this soon. So to be clear, what is it you can do soon? So this project called ABC is really an umbrella for how can you develop Angular applications the same way we do at Google. So this is assuming you have similar challenges about scale. If you're an enterprise with a lot of developers and a lot of code, you probably have some of the same problems we had. So I want to tell you how we meet this 2-second SLO, which is approximately what we have, with thousands of source files in the program. And the basic principle we're looking for is incrementality, which is the time it takes for me to rebuild the project, whatever the thing is that I need to see in the browser, needs to be proportional to what I changed, not the size of the whole project. And we all have a way of doing this. Many of you already do, which is to split your project up into multiple packages. So now we can compile each of these packages independently, and as long as our packages don't get too big, the time to do that is going to be smaller than to build the whole project. Angular has several packages, and then there are these tools you can use to help you with the workflow that comes along with splitting up into multiple packages. And we knew this from the beginning. When we developed the Angular ng module inside of Google, we were already going to be using it to split packages. And so not only is ng module the unit of code reuse in Angular, but it's also the smallest thing that you could compile. So all of the components that you want to compile, they need to know the compilation context, like what selector and what providers are available. And so we can compile each ng module in isolation. And at Google, most of our source directories are their own package, and so most of our ng modules are actually compiled independently. So to make this work, most of the workflow tools out there are going to be hard to use when you have hundreds of packages in your project, which is what I'm describing here. So across these fine-grained package boundaries, what we really want is for the build tool to be able to keep our entire project up to date all the time and not have to do some release engineering step in between where we say, oh, I rebuilt package A, let me npm link that or copy that or put it in my repository and then fetch it again so that I can see it show up in package B. So that's what we're looking for. So before I show you how we solve this, let me just set up an example. This is kind of like what Google looks like. Maybe this is what your enterprise looks like. We have this company at the top level. And then there are a bunch of divisions. I work in the airplane division. There are 9 other ones. And then I'm on team 0. We don't have a very good team name. And there are 9 other ones inside of the airplane division. Then I have 10 ng modules that my team 0 maintains, and each one of those has 10 components. So we have a total of 100 components inside of what our team maintains. But if you look at the package structure, the application actually lives all the way up at the division level. So our division has this big app, and my team, along with 9 other ones, are contributing code that needs to run inside of there. And there's also this shared logo component, which I'll talk about later, which you can imagine is a placeholder for like some shared UI components that's written by one dedicated team at your company, and they follow your UX standard, and they're used in a bunch of different apps. So I'm going to talk through 4 principles that we use to actually, for a company this size and for that structure I just talked about, how do we make the build actually be fast? So the first one is, what do we have to rebuild? Let's say that I've just edited one component in this bottom bubble, the mod 0 that my team owns, also not very creatively named. What do I need to rebuild? And do I need to go back and rebuild everything that depends on it? So the arrows here are the dependency structure between the packages. And the answer is we want to really avoid this, because the deeper this tree becomes, the more we have to do these rebuilds, and they have to happen one after the other. So what we want to avoid doing is rebuilding something unless we have to. And when we have to rebuild it, or at least retype check it, is if it's API changed. If the API hasn't changed, then the changes are all internal to the package, and we don't need to touch anything else. And we can tell that easily because TypeScript gives us .d.ts files, which are a way to express the API of your TypeScript code. And Angular compiler produces a very similar file, ngSummary.json, specifically for this reason, so that when we hooked it up at Google, we would not have to have these cascading rebuilds. So the answer, of course, is if I have the same API, I don't need to rebuild. And if I've changed the API, I need to retype check the Team 0 top-level module, but I don't need to retype check the airplane app, because it doesn't depend on this thing. So we can constrain what needs to be rebuilt. The second thing we need is there is going to be some work that has to happen that is at global in the top level of the app. And that has to be very sensitive to scale. So for example, I'm going to show you a dev server that depends on my app. And it's going to need to read through all the sources in the app to load them in the browser. That has to stay super fast, even as we go to scale. And it's going to be order n, if you know order notation, because it has to look through all the sources. But the constant factor there we want to be small. On the other hand, there is work that we need to do that's not fast, like type checking and a lot of other things. If we do that work down in the individual package level at the bottom, we can rely on the fact that n there doesn't ever grow very large. There are not that many files in each package, and so it's fine for that to be n log n or whatever it needs to be. Third principle is just being smart about how we run compilers. And this applies to TypeScript and the Angular compiler and Sass, and it's a general principle. First of all, we want to keep it warm, so we want to keep a node program running, and it should have already parsed the compiler code itself. tsc.js, I think, was like 1.2 megabytes last time I looked. That's the TypeScript compiler. So we don't want to reparse that every time. We want to cache the abstract syntax trees after they've been parsed. But then there's also this thing that happens inside the TypeScript compiler where it needs to look at all the symbols in the AST and bind them to the symbol table, and those bindings can be cached too. So there's a fair amount of work we can cache between runs. And then we want to try to use all the available resources. So we want to be able to parallelize across your CPUs. The fourth principle needs a little bit more setup. So let's say I have this application, and I have 2 different ways that I use it. In one way, I'm in development mode, and I want ES5, so it goes straight in the browser. And in the other mode, I'm going to ship it to production, and I use Rollup for that. Rollup does a much better job of tree shaking and optimizing if you hand it ES6 code. So it looks like I might have to declare these parallel trees where the application is declared twice, once with ES5, once with ES6, and then all the libraries also need to be like that. It's obviously a maintenance nightmare. What we really want when we configure our build is not to say how to build it, like not to say what the output language is, for example. We just want to list what to build. So this is a really important abstraction. What that allows us to do is it says that when the dev mode builds, it requests the ES5 sources from the rest of the tree below it. And when the rollup needs its inputs, it gets them from the ES6 tree. So we only have to declare the tree once. The basic property here is that the build configuration is actually non-local. It depends on what is doing the build that determines what outputs we want. OK, and then the last thing, of course, is we want the ahead-of-time compilation to be part of our build tool. Angular is moving closer and closer to making AOT the default, and so we have to be able to fit that in our 2-second SLO as well. So no surprise, the B in ABC is Bazel, and so Bazel has the properties I just described. It's fast at scale. But let's look for a moment at how fast is it. So we just did this benchmark last week, comparing Bazel with a simple Express dev server to what you would have using today's state-of-the-art fastest Webpack setup. And the benchmark is that we're going to edit one file, and then we're going to measure the time until we can run the first line of our code in the browser. So we need to bundle and get all the JavaScript in the browser, and that's the end of the timer. And we're going to say that we're splitting our project up into packages. This is obviously beneficial for Bazel, as I just described. We're not going to have to rebuild the whole thing. And then for both of these, we're going to have source maps that take us all the way back to TypeScript. We're going to have synchronous type checking, meaning we're not cheating and skipping out on the type checking and then having it show up later. And it's all going to be bundled together as one JavaScript payload. And here's the numbers that I got from my machine, which is that, and this is a large number of files on the x-axis. So the right side of this chart is 10,000 files. As I said earlier, Google has apps that are at 6,500 files. So this is kind of the scale that we live in. And right now, Bazel is a linear growth, and it looks like Webpack is maybe more of a quadratic growth, just based on the number of data points I gathered. And the green line here is the SLO. You see that neither of us are meeting the SLO once we get to a certain scale. And so we have some more optimizations internally that we use at Google to keep it under 2 seconds that are not yet part of the benchmark that I'm showing now, which I hope can bring the slope of that line down. As I said, it's linear, so we just need to decrease the constant factor. And we should be able to get to 2 seconds for the sort of scale builds that you actually see in the real world. So I know that some of you are about to take out your phones. You're thinking about the tweet you're going to write, which is that I just said, like, better than Webpack. This is not the story at all. We love Webpack. So first of all, these are totally good at different things. Bazel is really good at understanding this graph of your packages and being able to optimize your build based on that. Webpack is a great development server. Bazel doesn't have a development server. I wrote a quick one in Express, but there's a lot of things that Webpack does that you still need. And of course, these are both open source projects, so we want to learn from each other. I've already been chatting back and forth with Sean Larkin about how we can work together to make sure that both of these systems are fast and good. But other than speed, there are a few other things to Bazel's credit that I think recommend it to us, which is, number one, this is the same build system that we use at Google. So we have a lot of miles on it. We know that it handles lots of use cases. It works for both front end and back end. It can compile Java and C# and C++. So if you really believe me that you want to have this graph and you want to be able to make a change and then build everything that depends on it, then when you change your data schema, you kind of need to that affects both the front end and the back end. And so there are a lot of situations where you want to, it's advantageous to have them both in the same build system. Hermeticity is a fancy word, meaning it's sealed. So the results of building something in Bazel depends only on the inputs that you declared. So one nice thing about that is that we should never need to run a clean. Like, we should trust that the results are correct. I'll talk about another advantage in a couple minutes. And also, it has correct and synchronous type checking. As I said, we go up the graph and we find exactly which things need to be retype checked depending on what changed. I'm going to do a quick demo. Before I start that, I'm going to briefly describe how you configure Bazel. So as I said, we're splitting it up into packages. Each package is going to have a build.bazel file. And then inside of there, we can declare a bunch of rules, which is basically just a group of input files and their dependencies. But as I said before, no instructions about how to do the build. And in the future, we think we can actually generate these build files from your TypeScript sources. But if you want to play with this today, we don't have that yet. So you would actually write one of these files. And inside of that file, this is the sort of thing you would see. So we load something from @Angular, like you're used to from TypeScript, except that the syntax is a little different, and we're loading from index.bzl. So we're loading Bazel code here. We're going to load the ng module symbol, and then we call it to declare a rule. So this is the build file at the top of the airplane tree. And so this is declaring the airplane app. It has some sources, it has some assets, it has dependencies on these other modules. We tell it what our TS config is so that it's the same TS config between the editor and what Bazel builds. And note that the syntax here, I don't have time to explain, but the / means at the root of the tree. And so this TS config file is actually shared for all of the divisions in the company. I just point that out because we do that at Google to make sure that all of our code is uniform, and it helps us to maintain all this stuff at scale. So let me hop over to a terminal and show you just a little bit about what Bazel looks like. Notice that I have a new device connected. Thanks. OK. So the first thing I'm going to do is run the Bazel command, and I'm going to do a query. The query is just to allow us to look at the structure of the build. Make that a little bit bigger. So we're in airplane. See how I can type up here. Team 0. And this is the ng module rule that I just showed you in that file. But what's more interesting is to look at what it depends on. So we can do there are a lot of different expressions that you can write here when you do a query. So I can ask, what does this depend on? In other words, what am I going to have to build first? And it goes and says, oh, all 10 of my modules need to be built, and it shows me all of the source files that are included there. That's still a little hard to read. Let's ask for the output to be a graph. And I'm going to open, it produces GraphViz, so I'm going to pipe that to something that'll pop it open. So this is really wide. Normally, your dependency tree would be tall and not so wide, but in this example, I have in this example, I just happen to have these 10 modules to illustrate the scale. So we can see that my team 0 has these 10 modules, and each module depends on the 10 component files. And they all depend on the same TS config. OK, so now we're ready to actually do our first build. So I'm going to do Bazel build of airplane team 0. So this is going to build all 100 of my components. First, it's actually building the TypeScript tooling itself, because we do everything from head. And now you can see on these lines, it says that there's a worker running. That worker is the thing where we kept the compiler warm. And so this was not an incremental build. This was my first time build. Let me run it again. And this time, I'm going to put Bazel into watch mode by running a different command, which is iBazel. So iBazel is going to build this thing once, and now it's waiting. So let's go to an editor and find one of these files inside of team 0, mod 0, component 0. And I'm just going to make some trivial change here and hit save. And you can see on the other terminal, it immediately rebuilt. And the time here was 1.14 seconds, which is actually not that great. But I think we can optimize that more. It is under our SLO. And what we see typically is more like 500 milliseconds for a rebuild. So there's some optimization still missing here. OK, cool. So let's actually, I'm going to cancel that. And instead of building, let's go all the way up to the airplane level and run the dev server. This is the same dev server that I talked about in our benchmark. And this one I'm going to do iBazel run. So I'm going to run the dev server, and I'm going to keep it in watch mode so it should see the changes that I make. OK, so we're going to build stuff. Now, this is going to take longer, because now I'm building 1,000 components, everything in the airplane app. Let me point out that there are 3 workers running, because Bazel sees that I have 4 cores on this machine, and it uses all but one of them to bring up workers. So I'm actually parallelizing my build here. And I needed to talk for about 3 more seconds there. 2, 3. Why would this be slower if I'm on stage than it was when I rehearsed? Doesn't make any sense. OK. So let's go to the browser and take a look at this app. I'm really bad at UI. I write build tooling. So this is about the best Angular app I've ever written. Actually, I give myself some applause for this one. But you can see every one of these numbers is actually an Angular component that just has a trivial template to generate to render a number. But it's going to serve the purposes of showing the scale. And as I said, we expect that that things like source maps will work. So so I can open in Chrome DevTools, airplane, team 0, mod 0, component 0. This is the same file we were just looking at. And if I make a change now, so in the background, it's rebuilding just the thing that changed. Now it bundled all the JS, and it's bringing it back to the browser. And it's doing all the module loading. And I did something that failed. OK, well, I'm not going to debug that live. So the last thing I want to show you is I mentioned that the shared logo file is depended on by other places in our company. So I can ask the Bazel query to show me all of those places with this rdeps command. So now it's loading up all of the build.bazel files, understanding the structure of the build, and it's going to give me this graph that shows everything that depends on the shared logo. And I didn't bother making dev servers for all the other parts of the company, but you can see the biofuels division and all the other ones depend on this component. So that means if I make a change to that component, what I really should do is build everything. And this ... is just a recursive glob. Even with my 4 cores on this laptop, this is not going to finish in time. But that doesn't mean that I can just wave the problem away, because we really do have these big initial builds to do. So I was standing at somebody's machine, and I saw all 12 of their cores were busy running the TypeScript compiler. That made me really happy. I like that. But what happens if you need more than 12 cores? Well, we have lots of cores in the cloud. And since Bazel is hermetic, we know that we can rebuild any one of these things by just having the right input files available. And so we can actually, using this Bazel build / Bazel build farm, we can ship any one of these TypeScript compilations to happen on some other machine. So I can get plenty of cores, and I can parallelize even my initial build out over a lot of machines. And at Google, we rely on this very heavily. So I talked about how to make things better for users. I have very little time to talk about how we're going to make things better for the end user on the web. But one thing we use is Clojure compiler. I'm not going to go into any detail, but this has actually been available since Angular 4, and this is our canonical demo repo where you can see it working. The size today is 39.7K, complete JavaScript download to get a hello world on the page if you use the Clojure compiler. But you shouldn't get too excited about this yet, because the advanced optimizations that it does includes renaming all of your properties, and if you're not careful about the way you access your properties, that can break your application. And also, using third-party libraries takes some extra effort, because some of these libraries can be bundled together with your application. Some of them have to be loaded externally. So we're working on that stuff. Let me tell you what the state of things is. So today, supported Clojure, you can try that out. And experimentally, you can learn more about my demo by checking out this other repository. The fact that my demo didn't work on stage, I hope, is not a reflection of whether it will work for you when you try this. It is experimental. That's why we have this new labs thing over here, so don't get panicked. So what's coming soon is Angular itself is switching our build system to Bazel, because we need these same advantages. We have a pretty big code base. And part of that is that we need a rule that allows us to package up code as an Angular library to ship at 10 p.m., because that's how Angular is delivered. But it means that component libraries could do this too. We need to do more benchmarking of the performance and try to improve the performance. We need to cover more of the ecosystem. So we need like a rule to do testing with Karma. Windows support is underway, and we actually have part of this stuff is now working on Windows. We have a CI for it. Just haven't finished rolling it out to the whole demo. And then next year, we're going to continue the experiment by figuring out, can we do code splitting faster? We think that we can move some of that algorithmic complexity work out of the global level down into individual packages. We want to make Clojure compiler better, integrate it with Bazel, make it not break your app. We want to generate those build files, like I said. And then the big question is, if this build tool is great and everybody should be using it, then we would start looking at how to allow you to use it inside of the Angular CLI. You wouldn't have to interact with Bazel itself. It would just be behind the scenes. So you can come talk to me. I will be at the Narwhal Booth. I have some T-shirts to give away that say Bazel on them, thanks to the Bazel team. You can sign up to be an early user of this thing if you think that your enterprise would benefit from it before we've got it fully baked. You can also email devrel@angular.io. And the reason that I'm at the Narwhal booth is that we've been partnering with Narwhal, and the next talk I encourage you to listen to carefully, because their new NX tool for handling enterprise scale builds, we have a branch of that that's actually using Bazel, and so that's one of the first places that we think we might deliver it. I'll be at the Basil Conference next month. Stop by if you're in California. Here's the link for everything you need, so more information, link to these slides. And if you want to have some updates about when this is working better, then I will put those on Twitter. Thank you very much.
Thank you.